Good evening. It's my great pleasure to welcome Chris Wilkinson to the AA. I think it's the first time that Chris is giving a talk here. I think you can't open any architectural magazines, journals these days without noticing that there is another new project from the practice. And I think it's been really incredible to see that the number of different projects ranging from bridges to museums, Jubilee Line stations, a whole host of different projects that combine a lightness of touch, working with new materials, working with incredible structures, which is coming out of the practice. Chris formed his office in 1983 and recently has renamed it with his partner Jim Eyre, a graduate of the AA, as Wilkinson Eyre Architects. I'd like you to join me in welcoming Chris Wilkinson.
Thank you, Motion. Can you hear me? Is the microphone on? And could I have the first two slides, just as a backdrop? Well, not necessarily the lights down, but yeah, okay. Right, I'm very pleased to be here. I've never actually spoken at the AA, so it's a first for me. And I'm afraid I'm giving a lecture, which is a sort of trial for a lecture I'm giving in 2 weeks' time in Taipei. So it's not specifically necessarily just for students. It's our general work. But I'd like to start by saying that I think it's a really great time to be practicing architecture. And you're very lucky to be studying at this time, because we're in the computer age and amazing new possibilities, both in design and construction, have opened up through technology. Whilst the 20th century saw the start of the modern movement and the rapid development of technology, spectacular failures marred people's confidence in modernism. There was the destruction of our town centres for road improvement schemes. There were social problems caused by the housing programme, and there was general mistrust of architects and planners, which wasn't helped by the proliferation of badly designed buildings just after the war. And it made it much harder for later generations to do anything new. But now attitudes have changed towards innovation and advanced technology, and there's a newfound confidence in design. At the same time, the boundaries between art and science have been blurred. Many artists have moved from the confines of traditional materials to new technology, and conceptual art has long since lost the need for an object. Science museums are now using artists to convey scientific principles. New developments in material science and nanotechnology are coming into range, which will allow us to manipulate the structure of building materials to suit our needs. Computer programs are becoming ever more sophisticated and easier to use, so designers now have access to complex geometries which were previously beyond all but the serious mathematician. At the same time, engineers have 3D stress analysis programs which make it easy to determine the structural possibilities and therefore make complex buildings much easier to produce. I'm excited by all this technology. I like to use the latest technology because I believe in building buildings of today. However, I still see myself as an artist rather than a technician. My primary concern is with aesthetics, and I'm passionate about what buildings look like and how they feel inside. The technology is only a means to an end. Architecture is a big subject. It challenges all our senses. Our buildings have to be functional, but we always look for something more, something which provides depth and lifts the spirit. We strive for innovation, because as with art, there is something exciting and stimulating about the new. Inevitably, there are certain themes and preoccupations which keep reoccurring, so we're able to learn from past experiences, but we start each project with a clean slate. Now, I'd like to show you some examples of our work in which we've used technology, the technology of the day, and we've drawn inspiration from art, science, and nature. I'll see if I can make the slide system work. Starting with my own house in Dulwich, my wife Diana is an artist, and the need to rebuild our conservatory caused much soul-searching until we realised that we didn't actually need a conservatory. What we needed was a room which opened up onto the garden and allowed us to enjoy the view. We remembered an installation by James Turrell on the left called Meeting House. Some of you may have seen this, in which the roof opening and a simple space seemed to have so much impact on the space. The sky, he calls it an ever-changing sky view, and it helped us to think about the control of space and light. We ended up with this small building, 4 meters by 4 meters by 3 meters high, with a 2 meter by 2 meter roof light in the center. And the roof light has sloping sides which open outwards, so it gives this expansive view. The frame is concealed, so you can pretend that there's no glass there. In fact, it's double glazed and it's K-glass, so it's highly insulated as well. On the James Turrell version, there's no glass. But the great thing about this is that you're able to feel close to nature. When it rains, you hear the raindrops above, and the raindrops make patterns on the glass. When the clouds move past, they seem to invade the space. And it seemed to me that there's something to be learned from, it proved to me that there was something to be learned from the artist, which architects don't necessarily know. I mean, Le Corbusier always had the sides of opening inwards, which makes it an introverted space, and it occurs to me that this actually an expansive space might be better. Just a last look at this space, and there are a couple of other things that help. It's little lessons to be learned from the modern movement, particularly Mies van der Rohe. The floor, which is a stone floor, goes right through from the inside to the outside. The wall on the right-hand side goes through from the inside to the outside, and it draws the eye through. Using modern technology, frameless glass, it's possible to be sitting inside in perfect comfort, but to feel as though you're outside. So, I'd like to move on now to our project at the Science Museum, which is a bridge. This started by an invitation from Jasper Jacobs to join his competition team with Bryn Bird of Whitby and Bird. And the reason was he felt there was an opportunity to build a bridge, and we designed a bridge and won the competition. And the discussion with Bryn Bird was one that I'll always remember. We came to the first meeting with some images. These were the two images I brought, Spider's Web and a postcard from Australia of a sculptor called Ken Unsworth. This is called Stone Circles 2, and what I like about it is these river boulders are supported just above the ground, about 300 millimeters above the ground, on very fine cables. And it's got a sort of dramatic tension to it. Bryn came with the Gossamer Albatross and a sculpture by Danny Lane in glass. And we had this dialogue about using very fine cables and glass to try and move the technology forward, to try and make it as challenging as we can. This was the first sort of computer drawing of the scheme on the left. It's hopelessly out of scale. In fact, the cables are only 1.5 millimeters, about the size of a double bass guitar string. You can see on the slide on the right, you can actually that's the finished bridge. You can only see the cables because there's a black curtain down. This was on the day it opened, and they provided a black curtain which they unveiled, and we were able to get a photographer in to photograph it because the rest of the time the cables are invisible. And that was what we tried to achieve. We wanted it to be light, and we wanted to show that technology has moved forward. The principle of this bridge is quite simple. We've used glass on its edge, and you walk on the top edge of the glass. So you've got planks of glass which are 20 mil thick, 100 mil high, and it's 1.8 meters wide. And it's used in a very similar way to the Danny Lane sculptures. You get this very interesting sort of chunkiness of the glass on the side. In fact, the weight of the glass helps the structure. It provides a download which helps the tension structure from movement. The cables, you can see, are very, very fine. They're attached to this stainless steel member at the top, which has piano keys, or a kind of piano key, to tension them up. And that in turn is connected to the main structure via stress gauges, which connected up to computers. And also there are various cables that, well, each cable is in fact attached to the computer as well. These cables go from this steel crescent shape down, can wrap round a little peg underneath the 25 mil channel underneath the glass, then underneath the deck and up the other side. So it's like a sort of tensegrity web in a way. And I'm not absolutely sure what the difference between tension and tensegrity is, but for me this is a tensegrity structure in the way that Buckminster Fuller talks about tensegrity structures. You can see we've got bigger cables holding it down, and you can see people walking over the bridge, although it is a bit scary at first. Now, one of the important, on each project there are various aspects which we're interested in looking at. It's not always just the basic sort of structural elements, it's not pure architecture, it's all sorts of things. And in this instance, we explored the possibility of making it active rather than static. It seems to me that structures, and buildings for that matter, don't need to be just static. They can have more life to them. And in this instance, we worked with the artist Ron Geeson, who wired the whole thing up. He put sensors underneath the glass deck. He connected all the cables up, as I mentioned, and he's got the stress gauge as well, and he's got video cameras on either side. We'd originally, in the competition, we'd suggested that the bridge should hum, and the museum were interested but a little bit worried about the noise. They thought it would drive people mad, or certainly the people in the reception area below. So they were delighted to think about it actually playing music. The interesting thing is that during the commissioning of the bridge, we did try to see how it worked, just the strings, and it does actually hum. It creates a rather deep hum when connected up to a speaker system, and it's just interesting, the idea that building structures can actually, they have a music to them. But in this instance, as you walk across the bridge, the loads change, and the notes change. So there's a kind of overlay of different sounds. So it's worth going along to try. At about the same time, we were lucky enough to win this competition in Bristol for another science museum. And this time it was in an existing building, which was a GWR railway shed. It was a listed building, early 20th century concrete structure, Hennebic concrete, if you know anything about that. Not a particularly beautiful building, but because it was listed, we had to be careful to not to knock it about too much. And you can see this diagram on the left shows the structure, in the middle, the structure that we retained, and on the top, the new elements we've added. And at the base, that's just the ground plan with the vertical circulation. And the model on the right shows the basic elements of this building. The sphere is a planetarium. It's a 15-meter diameter sphere, which is totally above ground. And you enter it from the first floor on a small bridge. When I say it's above ground, it actually sits half in water and half on ground. It's half on a reflecting pool that we constructed in front of the building. And it's intended that it will sit on a bed of mist, or in fact smoke more likely, but that's what they're working on. And then you can see the sort of main structure of the building in the first two floors, and a new level on the top, and a new glazed gallery on the north side. This is some construction pictures of the building. It's a fairly sort of heroic structure, I suppose you'd say, in concrete. And we had to take away lots of elements and keep the basic form. And we've set, on the ground floor, we've set the glazing back so that there's an arcade on three sides of the building. It gives it a little bit more depth, so that, a bit of light and shade. And then on the top, the new deck is that concrete element. Let's see if this works. Here, which returns up to provide the balustrade, and that's the roof of the new floor above. This is the planetarium under construction, which is a steel structure. And on the other side, we looked at trying to make the museum more accessible to the public. This is the street side. We built a big shop front. It's 90 meters long and 9 meters high, a big glass wall, and we tried to make this wall exciting and active, learning from the chameleon on the left. The idea was that we would try to incorporate some intelligent glass systems, and to have multiple light sources with a sophisticated control system, so that you could play the building. We wanted it's important that the ground floor of the building and the outside, the pavement on the outside, are exactly the same level. So it's very much like a shop. The space flows through from one to the other. And we won the competition really on the basis that they had this wall, they had this shop front, and they could sell their wares to the public. They can display things behind. These were 4 images at the competition stage, just showing what it might look like with the different lighting conditions. On the right, that's an image taken fairly recently of the glass wall, which hasn't got all the intelligent systems in yet, but it reflects the cathedral behind. And there's a couple of pictures of the North Gallery showing how the space will work. It's very enjoyable always to see buildings completed, because you learn so much from having gone through the process of designing, seeing them on the drawing board. On the right, you can see just about the building facade of the existing building on the right. This glass wall, the ceiling goes through. We've separated out the ceiling with a strip of glazing, and then this pod houses the lavatories. We had a shortage of space, core space in the building, and it provides also a sort of mezzanine floor and a route up to the first floor. So it's quite exciting. The other thing we did, which was, I suppose, sort of after Jean Nouvel, taking the glazing through beyond the line of the building, and we had a reason to have these extra spaces on the outside to give the building its length, but you walk through the glass facade to get it into the main building. A couple of details here: the glazing and the timber pod on the left, and the main building with its sort of rough concrete structure and new glazing systems and air handling systems within it. Now, sustainability is one of the main issues of today, and it's one that I'm very interested in, and I try to incorporate something in all of our buildings if we can. In this building, we're working with Overton Partners. Greg Chickaha is the M&E consultant, and we set him a task. We needed cooling because it's a deep plan building, and there's a lot of technology inside. It's going to get heat spots, so it needed cooling, but we didn't want to have any toxic refrigerant. He came up with a virtually untried idea of using eutectic salts, and these are the eutectic salts. They're housed in 100mm spheres, and there's a colour to the plastic that houses them. Now, the point about eutectic salts, and I'm not a great scientist myself, but apparently it changes state at 27 degrees centigrade, and it needs very little energy to give it this change of state. So there is a latent heat, a latent energy which comes from the changing of state, and we use that latent heat as our power source. The medium is water, so these balls are all housed, we call them Greg's balls. They're all housed in a glass tank in the main gallery, and in a vat of water, and that water is circulated to heat pumps throughout the building, which change it to hot or cold as required according to the temperature requirements of the day. We've also added thermochroic colouring to the balls, so that as they change temperature, they change colour, and you can see what's happening. It's kind of interesting, and it's working. But I have to admit, at the moment we've got a slight problem, because the water's actually sort of going a bit of a green colour, and we're having some teething problems on it. But it's certainly worth looking at new ways of solving old problems. I should say that it isn't just the eutectics that deal with it. We also have a displacement ventilation system, for those who know what that is, using thermal wheels on the roof. So we're always using recycled power. And I also should say that when we need extra power in that tank, which is our boiler, we can top it up with off-peak electricity at night. On the top floor, we have these big open-air spaces so that you can enjoy the views, but this is also a kind of education centre, so young children on sunny days are able to play outside, and a lot of the exhibits will be on these terraces on the upper level. We tried to get photovoltaic louvers here, but unfortunately it was beyond our budget and we couldn't get any sponsorship for it, so we've just got ordinary louvers, but they do move. Now, moving on to a project. I don't usually do this, showing a project which isn't going to be built. It was a competition scheme for the Imperial War Museum of the North in Manchester, which was won by Daniel Libeskind. We came fairly close behind, I think, and we had, one learns from competitions. It's an opportunity to experiment and try new things. In this instance, we we were looking at the idea that a museum needs to have a strong identity, but maybe that identity should be able to change. And we came, this was a very sort of windswept, rather desolate site onto the canal opposite the Lowry Centre. And it didn't have a lot going for it on the other side. We provided a big shed behind this sort of flexible, lightweight structure in the front. And the idea was we put all the light activities, that's the kind of restaurants, libraries, offices, that sort of thing, up in the front overlooking the canal in this flexible structure. And we wanted the structure to be able to change, to transform, like one of those kiddies transformers. And we built in these cranes as part of the main structure, and the idea was that the cranes could sort of reconstruct and change the elevational treatment. It starts off here quite benign with balconies with planting on, and then it becomes a little bit aggressive, and the cranes are holding armaments of war, which, since it was the Imperial War Museum, and then it can go soft again with projected images, and we're using the water as a fountain and projecting onto the water from the canal, and then light, and the cranes here become like angle poised lights, so they're quite benign again and soft. And it was rather interesting for us, the idea that buildings could dramatically change their identity. Okay, moving on to another project. This is one that's on site at the moment. It's the Magna project. It's in a steelworks in Rotherham. It's the old Templeborough reprocessing steelworks. It's redundant, or been redundant for several years. It's a huge shed, steel shed. And you can see on the left, this was, you get an idea, actually, this is, while it was redundant, these are people working on the structure, but it almost looks as though the process is happening. The steel is all rusty. It's actually very dark. This photograph has compensated for the darkness on a long exposure. There's little shafts of light comes through from these ventilators, and it's got this rather awe-inspiring sort of drama to it. There are two aisles like this, 450 meters long, and they're 7 stories high. It's a kind of crumbling relic of an important part of, in a way, our history. And we were given the chance, well, we had to win the job, but we were given the chance of transforming it into what they call a visitor attraction. I would call it a museum. And it was an interesting, clearly there was too much space to be able to use it all. We took the idea of providing pavilions within the space. You can get a glimpse of what we have in mind. It was themed to the elements, earth, fire, air and water, and we designed each of the pavilions to suit its theme. Now, I'll show the plan on the left, because you can see that these are the pavilions scattered about the space, and you get to them by walking on bridges and walkways connected to the main structure. So you never actually touch the ground. You're treading through space very lightly. And as you go, you see the process plant, which is still largely there. And this will be kind of lit up, and there'll be sounds and quite a lot of drama. But in each pavilion, it's to do with now or the future, whereas the building retains the elements of the past. It's a very interesting project to be involved with, and you can see here a drawing of our proposal with The air pavilion is conceived as an airship hanging in the structure of the roof structure, and then the earth pavilion is actually down in the cellar with this kind of fractal roof, and that's the water pavilion and the fire pavilion beyond. I'm just going to show two of these pavilions to give you an idea of what we're working on. The note from the sketchbook on the left, originally I saw it more as a kind of egg, but it's come out more like an airship. And a computer image from our office on the right showing what it's going to look like, the air pavilion. This is pretty well exactly what it will look like. We've been out to tender on this, and we have the subcontractor appointed, and fabrication is in process. It's for those that know, it's Hostaflon air cushions in a transparent fabric. They're laid horizontally and they're secured by aluminium extrusions, off which this tension structure holds it. The tension structure is connected to the main structure. Now, obviously, an airship wouldn't normally have this, but this was the most economical way of doing it, and we rather liked the idea of showing how the form is constructed. And of course, these are only fine cables, so you just get a glimpse of them in the darkness as the light catches it. And that's the access from a lift core on a bridge through this kind of orifice, which is based on a 747 jet engine aperture. Another view of the other end of this, and actually it's more dramatic than it shows here, because the ventilation of all these pavilions is a kind of using natural ventilation. So we've got two huge fans at the end which are drawing air in, and the air is expelled via gills, kind of gills on the side here. You can see this is a structure which runs through the enclosure, and that provides the deck inside. So as you go in, you enter a series of on a steel platform which got a series of holes in, and you're aware of the space around you. It's going to be a very interesting space. I can't exactly be sure that I know what it's going to be like inside, because I've never been inside an airship, but it is quite interesting, and you'll be able to see through the fabric. We're trying different fritting patterns into it to give it the right kind of depth to the fabric, so it doesn't look like a clear plastic bag. On the right, you can see that the air pavilion is standing right up in the roof space above the earth pavilion, which has got a totally different sort of heavy structure below. Now I'm going to just talk a little bit about the water pavilion, because one of the things that I'm interested in is form. I suppose we all are as architects, but it's always difficult to find new forms. And for the water pavilion, I was very keen on having a sort of vessel. By that I mean the sort of stainless steel structures which you get in breweries or in dairies that carry liquids. But we wanted something different. And Will Alsop's always done all these structures before, so it's quite difficult to find something new. We were playing around with forms and using this steel mesh just in our model workshop, just bending it around and pulling it. We got this rather interesting spiraling effect, which is very relevant to our particular site, because you can see here that the slab level changes. It's got about a 1.5 meter deep change in level right down the middle of it. So with this form, we were able to start on the upper level and go round to the lower level, and thinking of it as a giant sort of spiral. This was a sort of computer model of that idea of how one might create this spiral structure. Sorry, I have to go back. Lost one, but it's not essential. But I can say that this one is also under construction, in the sense that we've been out to tender, we've got contractors on board, and the steel structure is unfortunately on an orthogonal grid because it was more economical, but it changes at the ends to a very lightweight tubular structure which is visible, and the outside is stainless steel on the sort of parallelogram shape. It's made of thin gauge stainless steel cut on the bias, and I think it's going to be very, very exciting. But that building is, as I say, it's on site. Most of the building works are due for completion at the end of this year, and it'll be very interesting to see some of the results. Now, moving on to another project which we have in our office, which I've never shown before. It's a multiplex of 20 screens, including an IMAX, and we tried something different here, but it's using this spiral idea again. There was a reason for it, though. The site. This is a plan of the building on the right. The site was too tight to have all of the cinemas at one level. We couldn't even get it on 2 levels. He'd actually worked out at 2.5 levels, and 2.5 levels are not very good from an economics point of view. So we tried the idea of spiraling them around a central space. The thing about these multiplexes, they're all different size units, and we started by having a central space and just allowing them to tell us what size units they wanted. I mean, they kept changing from week to week, and I think they're still changing at the moment. But using, this is a big one with about 500 seats, and this is a small one with about 120 seats. Now, by stacking these, the big ones just one on top of the other, and the smaller ones up to 3 on top of each other, and changing the levels, we get this spiral form which comes from the Nautilus. It also, because of the shape of them, you actually get a kind of Nautilus effect. And the other interesting thing about this was that you can see here the auditoria are exactly as they need to be, in the sense that we have to work to a brief by UCI. We've got these escape spaces in between, and they're accessed by a spiral ramp on the inside. A couple of images of a model we had to demonstrate this to the client. You can get an idea of how exciting this space is going to be, because this spiral ramp is about 35 meters in diameter, so it's quite big. It's on it works out at about 1 in 20 gradient, so you can use it for wheelchairs as well, although it has flat spots and slopes. Then there are these escalators which skiff, so that you can short circuit the perimeter. You can go on a fast trip to cinema number 8 or something like that. And there were also lifts in this space which take you up to the higher levels. So it was quite tricky getting this one through, but they're all very keen on it now, and it may well be the next sort of form of multiplex to come. I'm 90%, 99% certain this is going to be built this year. Now, if you can imagine from a previous slide, you've got all these auditoria stacked on top of each other, and we found that the easiest way of creating some sort of form to it, and in fact the cheapest way of enclosing it, was to have a simple skin around the outside. But that skin would be very dull because there's no real need to have any windows in it, and it would be just a dead space. So we counteracted that by this idea of having a sort of different layers of transparency in the skin. we've ended up with a polycarbonate cladding system on the angle, which is the same angle as the ramp, the 1 in 20. And each one of these has a different level of transparency. There's 6 different levels of transparency, going from completely clear at the bottom to completely opaque. And we've painted the auditoria behind in bright colours. I mean, it's just a very simple, the first sketch actually, which was taking a spectrum and going round the building through the spectrum. So you see we've got roof lights above each of these spaces, and we'll have floodlighting at night, and that provides this level of colour which varies in intensity according to the level of transparency on the outside. It's kind of a simple idea, but I think it's going to be quite exciting. The Nautilus spiral breaks up at the entrance. This is this blue body here is the IMAX, and you enter underneath the IMAX, and that stands on its own 5 meters up in the air as a big volume space. And it's going to be placed on a plateau, so it's really visible from a long distance, and it's going to glow with colour. Usually planners don't like this sort of thing, but in this instance they like it because it's kind of a rather depressed area and they want something to liven it up. Now, moving to some projects which you're already acquainted with, but you maybe don't know the reason behind the design. Stratford Station, which is the end of the Jubilee line, the terminus, which was completed last year and has been fairly well received. This is one of our drawings showing it in plan, aerial view, and you can get an idea of the complexity of the transport, which it's kind of interchange hub. These lines here are the main Great Eastern lines, railway lines, and the Central line, and they're all at about 6 meters above ground, trundling through the site. This is the DLR, which comes in and stops at this station at the high level. This is the bus station, which exists and is a very nice fabric structure by Tony Hunt. And this is right through the middle of the site is the North London line. It goes through at ground level underneath all these lines here. And this is the Jubilee line platforms which stop at this point. And it was our job to try and tie them all together. The diagram on the left shows how it works. It was a competition, quite tricky competition. The brief came in a tea chest. There was so much to it, and we knew we had to break it down to a very simple building because Railtrack and London Underground don't build complicated buildings. They like things they can understand and they can afford. This it shows the concourse, and you can see that the concourse is split by the North London line going through. It's got the back of house accommodation. In fact, that now wraps round this side as well. Above there's a mezzanine level which connects the two sides with stairs, lifts and escalators so that you can cross over the North London line. That's in the space. Off that, the roof structure is supported, and on top of that is the roof. Now, you might ask, well, that's okay, how do you get to these high-level platforms? And the way we've done that is there was an existing tunnel here which connected up to the what was the existing station at this point. We put a new tunnel in alongside here which does exactly the same. So there are stairs and lifts going to the platforms above. And that was the simplification of what was a very complicated brief. Now, I'd like to talk a little bit about, I mentioned right at the beginning, the computer age. I guess the younger people here just have never known anything else, but for people like me it's still rather miraculous. We won this competition with a series of sketches, and this was a freehand sketch of a kind of curved shape, which just happened to look good, nothing more than that. The idea was that it opened up towards the oncoming line and towards the town. When we won the competition, we had to transfer that into a piece of determinable geometry, and we did this by digitizing the sketch and overlaying various geometries, and it turned out to be this ellipse, which is an ellipse about the center of the structure. In the past, ellipses were very difficult to build, but now they're very easy. They're just as easy to draw and easy to construct now. So, we've got the structure, we've got the simple space. The environment within it is very important in these stations, as you're well aware. One of the problems we could foresee was heat build-up, because this glass wall faces south. So we had to deal with that. I'm working with Lauren Butt, who is a very talented environmental engineer. We set in the problem, we didn't want any plant, we didn't want any ducts. We'd like it to be sustainable. And he came up with the idea of using the structural void. So what we've done here is we've peeled the soffit away to reveal the structure here, and put some grills at this point. And the hot air naturally rises and is drawn up the structural void. And this is solar powered because we've reduced the amount of insulation on the top of the roof, which is an aluminium upstanding seam roof. So when the sun comes out, it heats up the roof, and the heat draws the air through, which is helped by the fact that the structural zone is tapering from about 1.4 meters at this point to only 350 at this point. So it draws the air up like a thermal chimney. And what interests me about this is that we've all seen thermal chimneys at Sheffield University and places like that, but they always look terrible, for me anyway. They look like open-toed sandals. I've got a bit of a thing about open-toed sandals and grass skirts. I like the idea of sustainability, but I want to use it in an aesthetically enjoyable way, and I like to be able to use it with my kind of architecture. And in this sense, we've succeeded, I think. We've had to do one or two other things, like we've got shading devices to cut out the sun, and here we stop the glass short of the roof so that any hot air that's stuck in this place can get ejected. And all this is now possible to determine using computer thermal fluid dynamics. And these were the diagrams that proved it works, and it does work. Now I'd like to show you a little bit about the structure. Wilkinson Eyre architects have always been interested in structure. I can say that I've always been interested, and Jim, my partner, has always been interested, and we tend to attract people who are interested in structures. This is a very simple structure. It's a propped cantilever. These ribs, steel ribs, are fabricated. Actually, the fabricator used the same program as we use, so we were able to check that he was working to the same geometry as ourselves. I think soon we'll all be able to pass our drawings straight to the fabricators, and they can work from there, but at the moment they produce their own drawings. These beams are bolted to the base, which I'll show you in a minute, and they rest onto a truss, which you can see here, which is quite a deep truss. It spans 30 meters across the railway lines, but it's deep because we wanted it to be deep, and we made it as lightweight as we could. Here the engineers are Haider, a big firm of civil engineers, and we very much enjoyed working on the idea of making this structure understandable, really. We wanted the general public to be able to read it, to see how it works in the way that Victorian structures work. You can see that these huge ribs have to be bolted down, and we do that via this cast steel base plate. Each one of these weighs 3.5 tons, and we were able to sculpt these because they're cast. We wanted you to be able to see these stretch bolts which go through the top flange, through this base plate, and they go through the concrete slab to a plate below, and they're tightened up. And all that is very visible. And you can see that the finished building, you get to the structure is revealed. Very simple glazing system, curved glass, allows you to see it from both sides, and you can very easily see what's happening. You can see these stiffening flanges, everything. The space, though, we didn't want it to be a heavy space, we wanted it to be light. And it's a very difficult thing to determine what lightness is. Lightness can be achieved with heavy structures. And in this instance, we wanted the space to be filled with light. It's one of the feelings that I always have about Paddington Station. I love Paddington Station, the structure, but I find it very depressing inside. It's dark and it's full of diesel fumes, and it's simply that the Fox glazing system, which was done by the same guy who did the Crystal Palace, was very limited in those days. But nowadays we've got new materials, new ways of doing it. We were able to have plenty of glass in this building. It's all shaded so that it doesn't take direct sunlight. And we used the soffit in an interesting way. Again, working with Lauren Butt and using the Bartlett laboratories, we were able to determine a system of an extrusion which actually refracts the light, or reflects the light from the glazing system here down into the space. And we've put the lights, the artificial lights, on a platform alongside this glazing, and they do the same. They reflect from this aluminium extrusion down onto the space. We also have slots on the other side of the extrusion to allow acoustic quilting above to deaden the sound. And for those of you who've been in the station, you'll find it is actually quiet and quite enjoyable to be in. Now, each part of this building, you may think it's a very simple building, but it's quite complex, and there are a lot of different elements. Although there's a small palette of materials and colours, there are a lot of different structures and elements within it. On the south wall, the glazing's on an angle of 11 degrees. There's no secret to the 11 degrees, it just looked good on the drawings. And the glazing is supported off the truss that I mentioned with a tension system. It's nothing, no rocket science here, but it is quite complicated, and one shouldn't underestimate the complexity of building these structures. We only got this built by blackmailing the contractor and getting Arab facade engineering to back our case, because the contractor at the last minute said it couldn't be built. We knew it could be built, and it was built exactly as we drew it in the end. These aren't castings, these are huge. That's distance is 1.5 meters, to give you an idea. No, 1.2 meters, sorry. And these are cut out of stainless steel. They look light, but you couldn't pick one of those up. They're very heavy, in fact. But it gives this feeling of lightness, and there's been a lot of talk about lightness recently, and I'm always interested in that, because I think there is a kind of elegance which one should strive for, which I strive for. And it's particularly good when it's counterbalanced by a bit of weight. In this case, the weight comes from the rib structure on the other end, and the supporting structure for the truss here, which is in precast concrete columns. These are kind of well, they're almost nervy-like in a way. They're very sculptural, but they do take the forces, which is a big movement joint at the top, and they're supposed to look good as well. Damn, I'm still showing Caverna on this one. I tried to get them to take the sign down so many times that I whited it out on, well, I used Photoshop, but I got the wrong slide. Anyway, this is the finished building with this kind of what hopefully is an elegant ellipse shape. You could see everything going on. The glazing set back, big overhangs always help because you get light and shade. And on the inside, we've got the light, and it's very similar. I usually show that slide with our Hayes-Davidson image, which looks exactly like that if you look back in magazines. A couple more pictures showing the glass and the train going through the middle. All the components have been carefully considered. We had a big team, probably, well, certainly 10 people for a lot of the time, working to refine every detail down. And a couple more pictures of the finished thing. It is quite sizable. It's about 14 meters high, that roof, and so you can see it from the tower. Okay, moving back now to Stratford Market Depot. It was this building which really helped us to get underway as a practice. We won the job in 1991. We were lucky, I think, through Roland Paoletti at the Jubilee line. He was very keen to encourage new people to be involved in the line, and we were only a small practice of about 6 people at that time, so we were very lucky to get the chance to compete. We were competing again with Hyder Consulting, and they were called ASA in those days. And there were 10 engineers and I think 9 architects, or maybe there were 10 engineers and 10 architects. Anyway, we were the last to get paired up. So they had to pair up. The engineers were given a list of architects which they could pair up with. And by the time it got to our turn, ASA said they'd wasted 2 weeks. They said, "Can we come over and see you?" And I said, "I suppose you want to see our work." And I was a bit nervous because I didn't have much to show them. They said, "No, we want to get on and win the competition." So we got straight on and designed the building in 2 weeks and won the job. I should just say a little bit about why the parallelogram roof. It's 100 metres across and 190 metres long. This line cut-off is related to a safety requirement where the trains have to be straight as they enter the building. And you can see here, although the tracks weren't finished at this time, the track alignment was carried out by London Underground. And there are various curvatures. This is the maximum radius they were allowed to work to. And that led to this cut-off line where we could have the doors to enter the building. Rather than having a step facade, we cut it off. You can't imagine how pleased I was that happened to be about 30 degrees, which meant that we could have a diagrid. It's something I've always been interested in, but never managed to build. It's actually difficult to justify a diagrid against an orthogonal grid, except where you have a cut-off like this at 30 degrees. But a diagrid is a structural system where the members are in 2 directions and they carry load evenly across both in both directions. And this is in fact a space frame, purpose-built. It's 2.4 meters deep, and it didn't need to span the full 100 meters. We were able to put these tree columns in the middle to break down the span, so it actually only spans 40 meters by 18 meters. And there is an orthogonal grid which works with the diagonal grid. Okay, so this is the finished space. It's they needed a light, airy space. They had to have a clear 8 meters, and it's 8 meters to this point. I say that because the trays look rather small. I don't know why they wanted 8 meters, but they did. They wanted plenty of daylight. They've got these roof lights, which are like ribbons across the roof. We've got clerestory glazing down the long sides. We've got glazing on north and south. And it is a very light space and very pleasant to be in. On the north side, we provided quite a sophisticated glazing system working with Pilkingtons. It was in the recession we were able to get this suspended glass wall system for £250 a square metre, which is cheap. But it still looks good, and it's partly to do with the length of it being 100 metres. All this wind structure is there to counteract the horizontal wind forces, and you can imagine there is quite a lot of wind force on a glass wall 10 metres high and 100 metres long. On the south side, we wanted the light, but we didn't want the sun, we didn't want the solar gain, so we used this composite fiberglass material called Cowwall, which is an American product. It looks a little bit like a shoji screen, and we used it in an uninterrupted, simple way to make it as cheap as possible, and that has the same wind frame structure supporting it as the glazing system. Just a little bit, these are two images that I enjoy of the finished building. There is an element of luck in all design. There's an element of chance. I suppose the luck was this 30-degree acute angle near the entrance of the building. By returning some of the elements, this glass element, half a bay, we get to read, that's one layer. This is just the profile sheeting, just the kind of every steel shed type sheeting. And the structure supporting the roof, it's a V column, not because it looks good, but because it connects to two node points. You sometimes see this on these awful sheds, which is just there for decoration. This is the required structure for this building, and it's there to be enjoyed. And this view of the glass wall with you can see the roller shutters below, and we're seeing it from the control building, which I'll show you in a minute. On the roof, it's a very simple roof, and we were able to sell this building to the clients who are, after all, simple maintenance people, on the basis that it's a low maintenance building. We use this aluminium upstanding seamed roof, which comes in one complete length. Sorry, one complete length right across the 100 metres. It's actually welded. It comes in normally comes in 35 metre lengths, and we welded it horizontally so that it's in one complete length. And each one of these, so I'm losing battery I think, each one of these is a kind of zipping process to zip. It's a tray which is zipped to the next one, so that allows movement, thermal movement here, and it doesn't leak, which is good, because most big buildings do leak. And the control building, it's a teardrop shape because that was the only bit of site we had left, which is between the tracks. And it's a totally different kind of building. It needed this control room, circular control room, with as wide a view as it could have. And we've made the structure here an in situ concrete structure. So I do firmly believe that you shouldn't force these things. You have to use what's the appropriate materials and structure for the brief. Now moving on to another one of the buildings you may have seen recently for James Dyson, a vacuum cleaner manufacturer and designer. Interesting client to have. We first won this job on for a building on a different site, which was going to be 2,500 square meters, quite small, growing to 7,500 square meters. But by the time we'd got planning consent, it was too small. He needed much more. And he was able to buy this building here, which was already 7,500 square meters. And it had a site next door, and he asked us to get him into the building, which was a sort of 2-month process of refitting it, to extend the existing building, making it up to 10,000 square meters, and to get planning consent for as much accommodation alongside as we could. This is the finished building. We should just go back, sorry, just to explain. I'm sorry to do this. Right. It's difficult. There was a different headroom requirement for the new building. For various reasons, we wanted to separate it from the existing building. So we did that and used the space between as this kind of recreation area, but also as the entrance. So everybody arriving at the building goes through a pavilion in between the two buildings and then can go into the other two buildings. And because security is very important here, they don't get access to the main spaces. We sold this huge building, which is 250,000 square feet, 25,000 square meters, to the planners on the basis of this roof above. It's a floating roof above the trees. They thought they were going to get an ugly industrial building, and they thought this was an improvement on that. But from James's point of view, it is still just a shed. It had to be costed at a base price of £30 a square foot, which is what people work on. So it's an economical building. I'll go down to sequence. Sorry. Or it's this one. It's just confusing me a little. Okay. Right, the entrance. It's we were allowed to spend a little bit more money here, and we provided this crisp glass box. It's a double cube, 9 meters by 9 meters by 18 meters, and it's a kind of receptacle to collect people. It also is an opportunity. There's an opportunity there to display the wares, so it's like a museum inside, and it has to be light and in his terms kind of high tech, because he wanted to have something to relate the vacuum cleaners, which are sort of latest technology, with. But he also wanted it to be impressive for corporate clients, and we got into the usual old thing of putting a bit of water in front. In this instance, we used a reflecting pool, which is coloured purple, because he likes the colour purple, and it's the colour of his early vacuum cleaners. You enter the building on a glass bridge over this water into this glass space, underneath a canopy by Tony Hunt. And there's a light sculpture here by my wife Diana. Nepotism reigns, but actually Diana was appointed by James without referring to me. But he wanted a light sculpture which sort of brought this water to life. And you can see here what it is a series of what Diana calls light reeds. They're acrylic rods, 2.3 meters high, set into a bed of granite. And they're attached to a lighting system, fibre optic lighting system. The light boxes are in the under the slab of the building, and they wave around just like reeds, in fact, or like long grass in the water. And at about James's office is here. He overlooks this. At about 4 o'clock, they light up automatically, and other lights come on the building, and it starts to come alive. The whole thing starts to come alive, and it's kind of exciting way of using art to enhance the technology and bring the space and the sort of whole entrance experience to life. A couple more pictures of this one here gives you an idea of the effect of this colour. It gives the dark purple, gives the reflection that we wanted. The only problem is that if they don't change the salts start to occur on the purple, so it goes white, but they seem to have sorted that out. Inside, it's a lightweight Tony Hunt structure using standard steel components and a long spanning deck. The deck spans 10 metres, and because it's quite deep, we were able to use the troughs to house all the equipment that you get in offices. This is a design office, so there's a chilled ceiling in here. These are kind of cold radiators up in the space so that it provides a kind of air conditioning system, but the same structure is used in the main building. Now, the space between, this is still sort of an early photograph of the landscaping. It's kind of regimented, but there are a series of courtyards which people use, and there's another sculptor, Peter Burke, is working on a series of 40 sculptures that go in. There are people standing around in the space. And this is a bridge, a forklift truck bridge, which links the two buildings, and there's also a conveyor line, so you can see the products going across the bridge. The sort of last view of the front of the building with its glass wall, and the back, which has got all the guts, all the loading bays, and the same sort of roof, and very simple materials. I'm going to move on to a few bridges. Canary Wharf Bridge, which is no longer, unfortunately, but I have to explain a little bit, if you can bear with me, of why it's this S shape. It was a competition held by the Docklands, London Docklands, in their heyday, or just as they were leaving, in fact. They needed to provide some infrastructure which wasn't put in when it should have been at the beginning. You've got this quite a big span of water. This is South Dock and Heron Quays. And the only way of getting across is on the DLR or going on a long route round. They wanted to be able to cross from the Canary Wharf areas down to South Quays, but unfortunately this is the building site for the Canary Wharf JLE station. So the brief was quite complex. It required going from this side to this side with a bridge which could then be dismantled and re-erected on the line of the Canary Wharf once this station was finished, and also to allow for this dock to be expanded here, so for the next phase of development into the water. Our scheme, or I should say it's Jim's scheme, because it was a very clever idea he came up with, was to have these two segments of structure around a vertical pivot, well, around a pivot mechanism. One of them opens to allow boats through. This was a requirement, and it can always, because it rotates, it can realign to a new position in the future if required, and in fact this is required, and it is about to be realigned on this line of the tower. Then this part of the bridge can be dismantled and re-erected alongside, so you get two bridges for the price of one, which was the kind of thing that wins competitions, and it was built. Now, when we talk about bridges in our office, we talk about sculptures, because we see bridges as being opportunities for sort of sculpture. And in this instance, the structure of the bridge is a 900 diameter tube supported by cables from a mast which is 35 meters high. The mast we wanted to look interesting, so it tapers from about 1 meter at the base up to the top, but it's also a kind of elliptical shape, which is very difficult to construct. Also, they thought, this is the engineer, John Cutlack of Jan Bobrowski. He's not that tall, but this is how we started. It's a 1.6 meter diameter tube, which they roll in 30mm plate. They then cut a slice out of each side, and you get these two bits and weld it together, and you can get this tapering elliptical shape. Above the last part of the mast, above the top connection, we were able to cut it back again to give it a little bit more form. And you can see from the bloke on the right that it's quite a hunky bit of structure. You know, it's actually it has to compete with these buildings, which these kind of Chicago type buildings at Canary Wharf, which I think it does. It was about that time I paint in my spare time, and this was one of what I now call bridge paintings, which didn't start out with the idea of painting a bridge, but it kind of comes through in the psyche, and I think it's interesting that it's very difficult for architects and designers to paint in an abstract way. One has to try and release a different part of one's brain. One has to forget. You have to lose control, basically. But when you lose control, things come through from the back of your mind. Now, this is a drawing just showing how the structure works with this big 900 diameter spine beam, which has these brackets which support the deck. It's a timber deck. And to stop the wind, we worked on this idea of a stainless steel hedge. It's a perforated stainless steel sheet on a structure, and it does seem to reduce the wind load in the same way that a hedge does when you walk along the edge of a field. Bridges are for people. They provide space for they provide for movement, and I particularly like these photographs showing the bridge fully occupied in summer. It's an interesting route from one side to the other on this bridge because it snakes and it rises. It gives this kind of yellow brick road idea, so it's you can't see the other end when you start off, and that's quite unusual for bridges. But surprisingly, engineers seem to have accepted it. You know, they usually like things to be very straight and functional, but it's gone down okay. Just a little word about lighting, which is obviously very important these days. It's no good designing a beautiful structure unless you can light it at night. As a result of that competition, which we won, we were asked by Naeem Hussain of Overarp's bridge team to join him on the next bridge competition, which was for a road bridge up at Hume in Manchester. And the brief for this, the idea of this bridge was to celebrate the regeneration of Hume, which is going on alongside it. It used to be a no-go area. We thought long and hard about what would be the best kind of bridge to do this, and we came up with the idea that it had to be an arch, because an arch somehow has this kind of power. When you enter it, it gives you that sort of, you know that you're going somewhere. It's like a gateway. And the problem with an arch is you can only go through in one direction. So we put the arch on the diagonal, which means that you can cross it in all four directions, and it gives an interesting structural problem. In fact, Naeem Hussain, who's from Pakistan, really blanched when we first showed the idea of the arch on the diagonal, but he went away and he did this quick stress analysis, which I talked about earlier, overnight, and came back saying that it was okay. The only restriction was that we had to have, the arch was going to have to be very flat at the top so as to take out the torsional effect. Actually, it's at the third point for the engineers in the audience. I can see Hanif Kar up there. But when quizzed on this, we didn't want to have too heavy an arch because we wanted to win the competition. Did it have to be so big at the base? And he said, no, in fact, quite the opposite. It would be better if it was narrow and deep at the base and flat and shallow at the top. So we said, fine, that's it. And so we have this constantly changing section, which wouldn't have been possible probably until computerized cutting. Would have been too expensive. But Watson Steel were able to produce this box section with every plate being different, using their computerized pattern cutting system at a very economical price. So the this bridge was built for the budget price of £1.5 million. It was good when it opened. This was the fireworks, because we had Bobby Charlton and the whole was Manchester United there, and it was a very exciting sort of opening for the bridge. Getting near the end now. Butterfly Bridge in Bedford, another bridge competition, which was a third bridge competition we won that as well. So we had rather a good run. Again, this was with Jan Bobrowski and partners, John Cutlack. It's a very simple bridge. It's a kind of sculpture in a park. It's not a long span, 30 metres, and it's a footbridge. And the idea was originally that it should be a cable net with the deck supported off it, but apparently it wasn't structurally possible. So we ended up with this system of two inclined arches supporting the deck, a deck structure from the balustrade system. It's quite light and quite elegant. Now moving on to another bridge which we've recently completed at Maidstone. It's another footbridge, and it's another lightweight structure, and this time it's a cable supported system. We used a similar mast system to Dyson. Only this time the mast is quite sort of dense at the base, and it gets lighter as it goes up. The deck is perhaps the most interesting thing. We've patented this system, so if you want to use it, you'll have to come and ask us. It's an aluminium extrusion, 300 millimeters deep. They interlock, and I have quite a long span. Unfortunately, not a long enough span to go across without cable supports, because this is actually a 40 meter span, this bridge. But it's a very interesting system, and because they're laminated, we were able to get a curve out of the deck. So the deck curves. It's self-finished, so the top of it is there's no timber decking which can go wrong on you, and it provides the long span structure. We've used this wire structure as the can't think of the name of it, as the balustrading system, and you can see that the engineers had fun with all the connections. In this instance, it's Flint and Neil who were the engineers. And just the last project I'd like to show you, you've been very good, been rabbiting on for a long time, is our bridge at Gateshead, or Newcastle, you could say. In fact, it's a bridge sponsored by Gateshead to connect their quayside to the very successful Newcastle quayside. This bridge has been called the eyelid bridge because it's an opening bridge, but it opens on a horizontal pivot mechanism. To look at the drawings, it's two arches, one in plan, which is the deck which you walk on, and one in section, which is the arch which supports the other deck, with cables. And these two arches are connected at the base, and there's a hydraulic mechanism which helps it to rotate. And you can see here that the whole structure, which is like a cat's cradle, I suppose, revolves and opens to allow tall ships through. There's very few occasions where ships need to go through here because they can't go any further up the river, but they do have regattas and they have tall ships, so it was important for it to be openable. And I'm going to leave you with these two images which were produced for the competition at the time of the competition, and I'm absolutely sure that the bridge will look just like this, and it will be, as far as we're concerned, it will be a very exciting addition to the skyline in Newcastle. And I'd like to just sort of try and wrap it up by connecting a few strands together, really. The art and science. Well, there is a connection, and architecture seems to be one of the areas where the two come together. If you think of science as technology, we can't do without technology in architecture. But there has to be more to it than that. There has to be this other element which provides the depth and the uplifting qualities to architecture, and I call this art. So that's where the connection between art and science comes in architecture. Thank you very much.
Great, thank you. I'm sure before you rush off, there are going to be one or two questions, maybe.
Sure.
Chris? Maybe while you settle down, one quick thing. One of the things that you referred to was this moment when you were doing the drawing, and you said the contractors didn't think that it could be built, and you, by just doing the drawing, in some way you were very sure that it could be built, and it was built as per the drawing. In a way, I think, I don't know, this seems like a very interesting thing, that the contractor who's very familiar with construction doesn't trust the drawing, and you, by just sort of doing the drawing, think that you can build it. Yeah. I'm sure there's more involved in it, but what do you think about this sort of drawing, building, and the sense of knowing that something could be realizable by drawing?
Well, we all know that architects are arrogant people, and there is a kind of benefit from this arrogance in a way, although you have to be able to back it up. I think that you have to have a certain confidence in what you're doing. Also, I think it's fair to say that when you draw, you know what it's going to be like. I have never had a surprise yet, so I always say that I'll stop when I get surprised by what's built, because the buildings or the bridges always look like the drawings, and you can't fool yourself when you're drawing it. If it looks bad on the drawings, it's going to look bad when it's built. And I can't understand why there's so many bad buildings up, ugly buildings that don't appear to work visually, because the architect should have seen it on the drawings. It's quite clear. What you draw is what you build, and when it comes to arguing with a contractor, you have the benefit of at least knowing what it's going to look like. Now, he may say, but I know how it's going to work, But it's not always the case, because the process of drawing, and it is slightly more complicated on computers, I have to say, but the process of drawing is a process of working through how it's going to be built. So you don't just put those materials together in an abstract way. You put them together in a way that you know you can build it. So it's like a model, And so once you've worked out how it's going to be built, you feel pretty confident about it, and you argue for it. And in that instance, I think we needed professional help to show that it was right, and we got it from Arab's facade engineering, and it was very good that we were able to get that, and we built it. They wanted to turn it into a compression structure, so it would have been quite different. Going from a tension structure, it would have been a lot heavier.
Hanif, are you going to ask a tough question, or?
Fascinating, Chris, that you've got so much knowledge.
Maybe we can have a microphone. Sorry, I don't know.
Well, Hanif knows that I don't have much knowledge in technology.
I was going to say, you're one of those very rare architects that makes engineers look good rather than the reverse. How do you see the future? Because there's obviously this argument that Mosen's raised. There's obviously a problem of contractors forcing designers out of the industry, I think, in this country. You're one of those few people that can reverse that. You see a future. Are you actively doing anything to challenge it more than you just mentioned tonight?
Well, I do believe that things are getting better, and I started in an upbeat way because I find that when we're talking to steel fabricators, one can talk about shapes and forms which 5 or 10 years ago they'd say, get out of here, you know, we're not doing that. Now they're prepared to talk, and they're interested. We talked to cladding fabricators. I mean, a couple of weeks ago I was talking to the fabricator of that water pavilion, and that's quite complicated, but they'd worked all through it. They came to the meeting saying how they were going to do it. Wasn't exactly the same way that we were going to do it, but it was acceptable, you know, it's going to look good, it's going to be okay. So, you know, and it was within budget. And that's the sort of thing, you know, the air pavilion, Hostaflon fabric covering, we set them the task pretty clearly what we wanted, and they came up with it. In fact, they've actually enhanced it. They made it more interesting. It was their idea to use the tension cables on the outside. They were a little bit nervous. They said, well, it'll be a lot cheaper because we've got no structure, you know, and when we have structure, that's structural steel, it requires having another person involved, another subcontract fabricating the steelwork. So they always get taken to the cleaners by the steel fabricators. So in this instance, they were able to use to do it all themselves because the cable ties they make themselves, and they use trapeze artists and people like that to actually do it, and it's very easy and cheap. So they were interested by the problem, and they come up with the goods. And I think that as architects, we shouldn't be frightened to test people, you know, to push them to the limits. I think we do have a responsibility, though, to design things which can be built. You know, when I say can be built, I mean can be built to a reasonable budget, because, you know, it does set everything back. If a major building gets halted because they've got problems, it sets the whole of the profession back. We're now on a high, really, because there have been a lot of interesting buildings constructed over the last 10 years, and I think there are going to be a lot more, you know, and it's thanks to, you know, the big practices like Foster's and Rogers that have made things possible, you know, and there are a lot of other people who've pushed the boundaries, and so it's a very good time, I think, and I think we just got to capitalise on that and keep pushing the boundaries forward. Annie, it's a pleasure.
I wonder whether you could tell us something about how you place the work of your practice in relation to perhaps those who may be called the forebears, like the one you have just mentioned, like Foster and Rogers. And I mean this both from a technical and from an aesthetic point of view. And perhaps there is another question wrapped in this one, which is that how do you see the future of, for the want of a better word perhaps, but of high-tech architecture?
Well, I started work at Foster's, one of my first jobs, and I then went to work for Michael Hopkins and then Rogers. I finished with Rogers. So I had about 13 or 14 years working in these big practices, and when I left to set up my own practice, I was for a time overshadowed by what had gone before. You know, I was like a chameleon. I could work very comfortably, and I still could today. I think I could sit in one of those offices and work with them, you know, where and work with them. The difficulty is when you leave, you have to think what you are, you know. Are you just a chameleon, or are you going to do something on your own? And it takes a few years, you know. I mean, I suppose in my case, I had an enforced period of about 7 or 8 years where I was doing kind of very simple jobs, conversions and things. And I had a period where I was kind of detoxifying myself, getting all that out of my mind. So I actually feel now quite sort of separate from them. And I don't think, I mean, people obviously will relate any of our buildings to, say, a Foster building, because that's the way journalists work. And of course there is the same sort of thinking behind it, you know, the approach to solving problems, the approach to trying to get clear, usable plans, you know. And the other aspect, which is using technology, which I talked about, you know, the idea of, but we don't try and use other people's technology. We start with a clean slate. We have our own research programs in the office. We have quite a few firsts in our own terms, you know, where we've used new materials, new systems. We develop them ourselves, we underwrite them. We are starting to, we're doing this more and more, and we're starting to patent some of our work. I don't really, at the end of the day, I would be sad if everybody always equates us with other practices. And I also feel that the work we do is very different. You know, each project is very different from the other one, so it's quite difficult for people to sort of find a theme which runs through it. It's always hard to compare the bridges to the buildings, and the buildings now are changing quite a lot as well. I mean, we have the buildings we're doing, the museum buildings we're doing, we're working on a whole set of different criteria to the railway buildings and the industrial buildings. So we've got a number of different themes which we're working on, and a whole load more which I haven't shown you, which you know, until we get the first building, I don't like to talk about them. But we are working. Also, one of the things we've done, which is just by way of research in a way, is we're working on quite a lot of exhibition design. We've got 2 galleries at the Science Museum we're working on. And the reason for getting involved in that was, and it's a bit of a nightmare at one level, but what it does do is it exposes you to interactive technology, you know, very sort of more advanced things that people do in exhibitions, and we're trying to now relate some of that technology in our buildings, you know, with these sort of active walls and things like that.
Paul, and then I think
Paul.
Can I ask you a quick question about collaboration?
Yeah.
It seems to me that if we look at a project like the EMAX project, the overall form of the building results from a radical rethink of the spaces and their relationship with each other, but the spaces are generated by a functional requirement. They are a certain size and shape and having to go together. And the engineering solution then comes off the back of that. It's actually solving that problem. Whereas if we take some of the other projects, perhaps Stratford might be an example, despite the complex design problems you were having to address. It seems to me that the overall form of the building may well be generated by an engineering solution. And what I want to test, particularly with engineers sat behind me and in the room, is the nature of the collaborative relationship between your practice and the engineering practice at the creative stage, which is giving form to the building. Are they providing a menu from which you're selecting, or are you generating forms with them, or independently and asking them to test?
The answer is it varies, but we like to work as a team. I didn't go into all that. I mean, if I'm talking to architects, it's a slightly, you know, one talks more about how one works and how one does the buildings. We work as a team, and we like to have the main consultants appointed at the same time as us. We don't tend to appoint them. It's the client, direct appointments to the client. So we can sit down with the engineers, and we always make it clear that we don't want to sit down with the managing director. We want to sit down with their best engineer, or the best engineers they have. It may be the managing director, but it often isn't. So what we want is a group of talented people sitting around a table, and then we can discuss the way forward. And sometimes the way forward might be generated by the structure, and it might be generated by the engineer himself, in many cases. And there are quite a few engineers we work with on a regular basis who, we feel very comfortable with them because they do actually help us a hell of a lot. They're in, very creative and part of the process. Other ones, they're happy to wait till we come up with the solutions and they come and make it work. Both can work, but in the UK we're lucky and we're unusual in the UK to have engineers who are interested in architecture. You've got Hanif sitting there, and there are others like Hanif who actually enjoy architecture.
You won't be working with him, will you? Because he's one of the managing directors.
No, but they enjoy working with. They enjoy architecture. They have to enjoy it because it's much more work for them. On the whole, it's actually more work to do a structure where everything's visible, every joint is being considered, and they might only get the same fee. So it's got to be a labour of love, really.
Please. I was going to ask you, in terms of all the projects you've shown today, which are wonderful projects, how you see your practice in terms of the international arena, in terms of whether you see yourself moving more international in the future, or very much staying within the UK and Europe?
No, we are trying to. Our work's being published quite a lot now abroad, and we're starting to get inquiries, and it's always competitions, unfortunately, but we're doing quite a few competitions. And at the moment we're working on one in Paris for Peugeot Citroën, which will be a very exciting project if we were to win it, but we're up against 5 really good French architectural teams, so whether we can pull it away from them, I don't know. We just recently completed a competition for Wolfsburg in Germany, which unfortunately we didn't win, but an English architect did. It's very competitive in this country, and it's very competitive out there and abroad. But sure, I think the UK scene actually is good training ground for working in Europe, other countries in Europe, and it would be in the States if we were only able to work there. I think it's disgraceful, really, that we can't work in the States, but we have so many American architects working here. I like working with American architects, but I think they should reciprocate. We could walk away with the prizes in the States, the UK architects, if we only had the chance. Maybe things will change, but at the moment it's virtually impossible. Sorry.
Why can't you?
They have restricted practices.
Well, why can't we just reciprocate?
Well, Paul
is the expert.
Paul,
I've been sued by 3 American firms for naming them practicing in this country illegally. I mean, it's a dangerous territory to get into because you get sued everywhere your article gets published. So I've been sued in America and the UK. And that's just for saying this isn't quite fair,
it's not fair. It's certainly not fair. In fact, you can't work from one state to another. I mean, even if you're qualified in one state, you can't. It's ridiculous, really.
But the AIA don't like it either. I mean, they don't like the federal state problems. But it's very important that this issue is resolved.
I think
Because
so.
at the moment, I worked it out the other day, I think it was £10 billion worth of building work has been done by American practices from London in Europe in the last decade. That's a lot compared to what we're allowed to do in America, because you can't practice in America unless you're in partnership with American firms.
Any comments from any American architects? Yeah, I can see. Do you have any comments? Well, thank you very much, Chris. Thank
Okay,
you.
it was my pleasure.